Welcome to the deep dive. Today we're zeroing in on a really significant technological story coming out of China.
That's right.
It's about their advanced oceanic microscope called LICOMK++.
Hmm.
Now, for you following science, tech, maybe environment, or even international developments,
Mhm.
well, especially if you're gearing up for UPSC exams, this is a breakthrough.
It really is.
It's got some serious implications that we're going to unpack.
Precisely. And what makes a LICOMK++ so noteworthy, I think, is that it's basically the world's first oceanic simulation system giving us this kind of detail, a level we've just never had before about ocean processes.
Yep.
Think of it like moving from seeing the ocean in really broad strokes to examining it under a powerful lens.
A microscope, essentially.
Yeah, pretty much. So
That's-
our goal today is to understand what this tech is, what it's capable of, and crucially, why its emergence now carries such weight. And our information for this comes from a report by Union Rayo.
Okay, let's dive right in then. LICOMK plus AA. What exactly does that stand for? And, what's its core function?
Right, so LICOMK++ is short for LASGEP Climate Ocean Model K++. LASG is the Laboratory for Atmospheric Sciences and Geophysical Fluid Dynamics.
Okay, quite a mouthful.
Yeah, and IAP is the Institute of Atmospheric Physics. Both are important research hubs over there. But the key part is it's an oceanic modeling system.
Right, modeling the ocean.
Exactly. These systems help us understand how the ocean works. But what's truly revolutionary here, the real game changer, is its 1-kilometer resolution.
1-kilometer resolution. Okay, that still sounds a bit technical. Can you maybe give us more tangible sense of what that actually means for watching the ocean?
Yeah, sure. So imagine you're looking at a huge landscape, right? Older models, they might show you the big stuff, mountain ranges, maybe large forests, broad strokes.
Got it.
LIKEA plus bellyache. With this 1-kilometer view, it lets you zoom right in. You can see individual hills, maybe clusters of trees, even how a small river meanders through the land.
Ah, okay. Much finer detail.
Exactly. So apply that to the ocean. This resolution shifts our view from just seeing the large currents and general temperature zones to picking out much finer details, things like small eddies.
Eddies, like whirlpools.
Sort of, yeah.
Yeah.
Small swirling pockets of water. And they're actually vital for distributing heat and nutrients around the ocean. We can also see the intricate behavior of currents much more clearly. It's really a fundamental leap in our power to observe.
Okay, and this is where it gets really compelling, I think. With this microscopic view, this new level of detail, what new insights can scientists actually gain? What does it let them do?
Well, this enhanced resolution allows for a much deeper analysis of how the ocean influences our climate. That's the big connection. We can observe and model how heat and energy move within the ocean with unprecedented accuracy.
Right.
Think about those ocean eddies again. They play a huge role in transporting heat. And with LICOMK++B, we can study how they form, how they move, their impact, all in much greater detail than ever before. And this understanding also extends to how the ocean interacts with the atmosphere. That's a critical link, in the whole global climate system.
So what specific tasks can it actually perform? What are its practical capabilities, according to the reporting?
Okay, so according to that Union Rayo report, ITEL MK++ can track the behavior of ocean currents almost in real time. That's pretty amazing.
Real time.
Yeah. And it can integrate the huge amounts of data pouring in from satellites to constantly refine its models, make them more accurate. Think of it like constantly updating a weather forecast with new readings from sensors.
Okay. Nicholas.
And importantly, it can also simulate potential future climate scenarios. This is incredibly valuable, especially for coastal communities facing things like rising sea levels and changing weather patterns. And finally, it gives us a way to measure how much heat and carbon dioxide, the stuff generated by human activities, the oceans are actually absorbing. That gives us crucial data on the ocean's role as a buffer against climate change.
So this really goes far beyond just, theoretical lab research. Why is this specific development considered so important right now?
Well, if you step back and look at the bigger picture, its significance becomes really clear. We already know the oceans are basically the planet's primary thermal regulator, right? They soak up over 90% of the extra heat we generate.
90%, that's huge.
It's massive. And they also absorb a large chunk of the atmospheric CO, which has direct consequences for coastal environments, ocean acidity, all that. LICOMK++ gives us a much more precise instrument to understand these fundamental planetary processes.
And it sounds like this could seriously enhance our ability to predict those extreme weather events we seem to be seeing more and more of.
Absolutely. That's a major hope. With this more detailed grasp of ocean dynamics, scientists aim for more accurate predictions. Things like hurricanes, sudden shifts in major ocean currents like the Gulf Stream, other extreme weather phenomena that can have devastating impacts worldwide.
Yeah.
And the advantage of better prediction is just events, isn't it? Being able to anticipate allows for better preparation, more effective resource allocation, maybe even avoiding significant human suffering or catastrophe. Anticipation over reaction.
Definitely. Now, the article also mentions something I found fascinating, the context of technological sanctions. How does that factor into the significance here?
Yeah, that's a really important angle. What's particularly noteworthy, according to the report, is that the creation of LICOMK++ is seen, at least partly, as a direct response to tech restrictions imposed by the U.S.
Ah, interesting.
The system has been specifically engineered, optimized actually, to run efficiently using domestically produced Chinese hardware. This kind of bypasses limitations on access to certain foreign technologies.
So instead of being stalled by sanctions, they essentially innovated around them using their own resources. How did they manage that?
Well, the reporting suggests it's likely a mix of factors, probably developing more streamlined, efficient computational algorithms, maybe using computing platforms designed and built within China, and possibly even fundamentally new approaches to the architecture of ocean modeling itself.
A whole new approach, potentially.
Could be. By focusing on their internal strengths and resources, they've developed an independent solution to a critical scientific challenge. It shows a real capacity for indigenous innovation.
And the implications of that, they go beyond just this specific model, don't they? What's the broader message this sends out?
Oh, indeed. This sets quite a significant precedent, especially for other developing nations striving for greater technological autonomy.
Right.
It signals that even when facing restrictions on advanced tech, innovation driven by necessity and, a commitment to self-reliance can lead to major breakthroughs. It's a clear message, really, to any country seeking to foster its own independent technological development path.
Looking ahead then, what are some of the potential long-term impacts of having a tool like LICOMK++ available?
Well, firstly, it stands to be just an invaluable asset for the global scientific community. Anyone studying climate change anywhere. A more granular, detailed understanding of ocean behavior benefits everyone, regardless of borders.
True.
Secondly, those enhanced predictive capabilities, they could empower communities worldwide to better prepare for severe weather events that were previously, well, much harder to anticipate.
Wow.
Ultimately, as Union Rayo highlights, a LICOMK++ isn't just some sophisticated simulation, it's shaping up to be a vital instrument in our ongoing efforts to understand and hopefully address the complexities of climate change.
It really underscores that idea, doesn't it? That even strict limitations can sometimes spur innovation when the drive becomes strong enough.
Precisely. Necessity really can be the mother of invention, as the saying goes.
So to kind of wrap up this deep dive then, China's LICOMK++ it represents a remarkable step forward in oceanic modeling. It offers this unprecedented detail thanks to that 1-kilometer resolution, giving us essentially an oceanic microscope.
That's a good way to put it.
And this breakthrough has profound implications for climate science, for extreme weather forecasting, for managing our coasts. Plus, its development in the context of tech sanctions highlights China's push for technological independence, and maybe serves as an example for other nations too. For you, our listener, especially those prepping for UPSC exams, understanding this development offers really critical insights. It sits right at the intersection of science, technology, environmental issues, and international relations.
Absolutely. And building on that, maybe a final thought for you to ponder. Considering the impressive power of LICOMK++ and the whole strategic context of how it came about, it makes you wonder, doesn't it? In what other critical areas, tech, science, maybe something else entirely, might we see similar big advancements driven by this imperative of self-reliance, by that sheer power of innovation when it becomes necessary?
That's definitely a crucial point to consider moving forward. Well, if you found this deep dive valuable and maybe you have more questions or thoughts, please do like, subscribe, and leave us a comment below. We genuinely appreciate hearing from you. And just a reminder, all the information we've discussed today is based on the reporting from Union Ray YY. Thanks for taking this deep dive with us.